Part 7, May June 2015, Paper 12, Physics. Question 36. A potential divider circuit consists of fixed resistors of resistance 2 ohm and 4 ohm connected in series with a 3 ohm resistor fitted with a sliding contact. So the question says that there is a 4 ohm resistor and a 2 ohm resistor fixed along with a 3 ohm resistor which has a sliding contact. These are connected across a battery of EMF 9 volt. So this is a power supply which is a battery of 9 volt with 0 internal resistance. That means there is 0 lost volt. What is the maximum and minimum output voltage at this potential divider circuit? So we need to get the value of the minimum and maximum value of the output voltage. Let's see how to get the value of the output voltage. To get the output voltage, we need to find the resistance corresponding to the output voltage divided by the combined resistance into the EMF of the battery. Let's see how to find the maximum voltage. To get the maximum voltage, your slider should be in this position, which means it should be at the top of the 3 ohm resistor. So the resistance corresponding to this output is 3 ohm resistor as well as 2 ohm resistor. So the resistance is equal to 5 ohm divided by combined resistance. That means we have to sum up 3 resistors resistance. 2 plus 3 plus 4, which is 9 into EMF of the battery, that is 9. So you get the maximum voltage as 5.0 volt. To get the minimum voltage, the slider should be in this position. The resistance corresponding to the output is 2 ohm. 2 ohm divided by 9 into EMF of the battery. So the minimum voltage is 2 ohm. As you can see, the maximum voltage is 5. Minimum voltage is 2. It is in option B. Therefore, the answer is option B. Question 37. A cell of EMF 2 volt and negligible internal resistance is connected to a network of resistors as shown. So the EMF is 2 volt and there are resistors connected. We need to find the current I. As you can see, current I is a part of the circuit current passing through one of the 4 ohm. The easiest way is to go in a simple method. Show you. Let's see what is the combined resistance of this parallel circuit. The best way to find the combined resistance of resistors of equal resistance is that you divide the resistance of one of the value by the number of resistors you have. So as you can see, 4 ohm resistor, I'm having 2 resistors. So I'm dividing the resistance of one value, which is 4, by 2. So I'm getting the answer as 2 ohm. So when I'm having a combined resistance of a parallel circuit, I can find it using this method. So in case if I'm having 3, so in case if I have 3 resistors and each of 4 ohm, the combined resistance will be in that case 4 over 3. So you have to take the value of the resistance divided by the number of resistors. That will give you the combined resistance in a parallel circuit of equal resistance of the resistor. So the combined resistance here is 2 ohm. As you can see, it's a parallel circuit. So 2 volt is going to be 2 volt for this 2 ohm resistor as well as 2 volt for the same resistor. But as you can see, this is 2 ohm and the combined resistance is 2 ohm. Equal resistors splits the voltage into equal voltage. Like you can see, this is 2 ohm. This combined resistance is also 2 ohm. So 2 volt will be split equally. So this will get 1 volt. This entire thing will get 1 volt. So again, they are in parallel. So 4 ohm, this resistor will get 1 volt. This resistor will get 1 volt. Then what is the current? Current is equal to V over R. So V is 1.0 ohm divided by resistance is 4.0. So my answer is 0.25 ampere, which is option A. Question 38. An experiment in which alpha particles were deflected by a gold foil produced new insights into the structure of the atom. Which conclusion can be drawn from the results of the experiment? So this question is about the conclusion of Rutherford scattering experiment. So they are leaving an alpha particle into a foil, gold foil, and they are seeing the conclusion. So the conclusion, first one is most of the space inside the atom is empty because most of the alpha particle passed through the gold foil without getting deflected. So there is no much of deflection. Because of that, they are saying that most of the space inside the atom is empty. Very few particles were deflected from their path, indicating that there is a positive charge of atom occupies very little space. As you can see, when the alpha particle moves a little, a very few amount is being deflected. So that means that there is a positive charge. It's situated in the atom, right? Otherwise, there will be no deviation because alpha particle is positive, as well as something should be positive to reflect the direction. A very small fraction of alpha particle were deflected by very large angle, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. So very small fraction of alpha particle were deflected by a very large angle. So this shows that all the positive charge and mass of the gold atom is concentrated at that point. So basically they are talking about the nucleus. Which conclusion can be drawn from the results of the experiment? The first part says atomic nuclei occupy a very small fraction of the volume of an atom. This is something like they're talking about 3, the point 3. Let's see what is the option B. Electrons orbit the atomic nucleus. There is nothing stated about electrons. Some atoms of the same element contains different number of neutrons. Now they are not talking about different number of neutrons. They are talking about isotopes, which is not mentioned in this experiment. The atomic nucleus contains protons and neutrons. They are not saying anything about neutrons. Therefore, the answer is A. Question 39. A radioactive substance contains a number of identical nuclei that emits beta particle. Which property of these nuclei remains unaltered by the emission? Okay, so now we have to see by emission of a beta particle, which property remains unchanged. It's better to have a example which will make it easier. So you can see beta particle, there are two types of beta particle. One is positive, one is negative. Positive beta particle, negative beta particle. So consider this example. As you can see, this lead 214 is being converted to bismuth 214 plus negative electron plus antineutrino plus energy. So as you can see, due to the emission of negative beta particle, what is not changed? As you can see, 82, that is a proton number, is being changed to 83. That means there is a change in the proton number. But you can see the nuclear number 214 is not changed. So you can say the answer is nuclear number because that remains unaltered by this emission. Let's check the example 2. So you can see here 15 going to 40 with the emission of positron or positive beta particle with neutrino plus energy. So everything is conserved. This side is 15, here 14 plus 1, that is 15, here 30 plus 0, that is 30. You can see the proton number changes. So as you can see, when there is a negative beta emission, the proton number increase by 1. But when there is a positron or when there is a positive beta particle emission, your proton number decreased by 1. But however, so whatever the emission is, you can see the nuclear number remains the same. So you can see the answer is C. When a nucleus emits a beta particle, the atomic number changes, but the nuclear number stays the same. Uranium-238 nucleus undergoes nuclear decay to form uranium-234. Which series of decay could give this result? Okay, so you can see uranium-238 undergoes to form uranium-234. Now, which series of decay would give this result? Okay, emission of 4 beta particle. Emission of 4 beta particle. Okay, I'll just add alpha here for an example I'm taking. So as you can see, 234 plus 4, that gives me 238. 92 plus 2, that gives me 94. Here I'm having 92, here I'm having 94. That means I have to decrease my proton number by 2 steps. So the easy way is to add 2 negative beta particles. Try adding the largest value, which is the alpha, then try to balance it. Or you can try each option one by one. That is also one way, or you can try this method. So you need emission of 1 alpha particle with emission of 2 beta particle. So you can see emission of 1 alpha particle and emission of 2 beta particle. So the answer is C. Thank you.